All right, now we're going to solve this using implicit differentiation. Our problem is the same as before. We've got to get 2 miles across and 9 miles downstream, minimizing our cost function, where it costs us $8 for every length unit across the river and $4 for every unit on the land going downriver. Our answer is going to be that we want z equal to 2 over the square root of 3, where z is this length here, asking how far down do we aim, leaving 9 minus z to be the portion that is exclusively on land. Now, the way Gonick sets this up is he starts with what we're going to call equation 1, y squared, and he calls what I'm calling zx. Right, so I put this is x. He said this is 9 minus x, and this is x. It's just a label. Rose by any other name is a perfectly valid approach to algebra. I'm going to stick with his numbers just because I'm looking at his answers. I don't want to mess this up. So y squared minus x squared equals 4. This is just a rearrangement of the Pythagorean theorem, right? So with this being x, x squared plus 2 squared gives us y squared. So y squared minus x squared gives us 2 squared, which is, of course, just 4. So if we take this, we've got a setup for implicit differentiation that we're going to deal with equation 3, but we'll get to that in a second. Let's look at equation 2. For equation 2, we've got the cost function. So we're saying cost as a function of x, right, or what I was thinking of z. Right, so he basically has this same setup, but again, we're going to relabel some stuff. So this is 4 times 9 minus x plus 8y. And then we're going to, well, basically what we're going to do is we're going to use implicit differentiation on both of these equations on their own. We're going to solve for y prime. How does y change as we change x? And we're going to put those together to solve for x. So let's get right down to it. So we won't do that over here, but we'll say 3, which we're going to get from 1. We take the derivative of this with respect to x. Right? D dx of y squared minus x squared equals 4. Well, some of this is going to be easy. Some of it's going to be a little bit trickier. So that's definitely just going to be 0. This is going to be just negative 2x. And then here we've got a chain rule thing where we're saying y is implicitly a function of x. So how does y squared change as we change x? Well, it changes by 2 times y prime, right? Which is our dy dx, or what we were calling dy dz somewhere. It doesn't matter at this point. Okay, 2y times y prime minus 2x equals 0. Now we can solve for y prime. We're going to say, well, we move this over. That's just going to become 2y times y prime equals 2x. Divide both sides by 2y, and we've got y prime equals x over y. So this is the derivative of y, just dealing with sort of the pure length of y. Now again, we can think about this in this marginal cost, marginal benefit scenario, right? So just like what we were doing here when we were thinking about how much do we add to our costs, well, this is telling us how much do we add to the length of the river pipe, which we can then multiply by 8 to think about as a marginal cost. Let's see. So we've got y prime, but it's got 2 unknowns in it. So we can't quite plug it into here just yet. All right, now we're going to take this equation and we're going to take the derivative of that also. So this, let me go ahead and simplify up here. This is 36 minus 4x plus 8y. And we're going to take that derivative and we're going to set the whole thing equal to 0. So we're going to have c prime equals, well, that's just 0, minus 4x. We're asking how does this all change as we change x? So we're going to have minus 4 plus 8y. Okay, so that's going to give us plus 8. How much does y change as we change y? Well, it changes by 1, right? dy dy equals 1. But it's a chain rule thing, so we need to also have dy dx, and that's going to ultimately give us dy dx. So we need 8 times y dy, which is 1, times y prime, which I'll call y prime, which is just dy dx, right? Different notation. I'm going to be a little bit lazier down here. So this is c prime equals minus 4 plus 8y prime, which Gonick is calling equation 4. So with this, well, we can say we want this to be equal to 0. So equals minus 4 plus 8y prime, which means positive 4 equals 8y prime, which means y prime equals 4 over 8 equals 1/2. So from the cost function, what we expect, treating y as implicitly a function of x, we find y prime for our solution, right? Y prime, when we're saying c prime, must be equal to 0. Y prime is equal to 1/2. Now we set that equal to here. So, of course, y prime has to equal y prime. So that means x over y has to equal 1 over 2, which means x has to equal y over 2, or y has to equal 2x. So if y equals 2x, what we can do is we can plug this into equation 1. So 2x squared minus x squared equals 4. Now the thing to be careful of here is this is y squared. Y is 2x, so we need the whole thing to be squared, right? Not just the x. So we're going to have to square the 2 also. So we get 4 times x squared when we square 2x. 2x times 2x. Let me just write this out to be super explicit. 2x times 2x is going to give us 4x squared, right? We're getting the x times the x. We're getting the 2 times the 2. So 4x squared minus x squared, well, hey, that's just 3x squared equals 4. X squared equals 4 over 3. And hey, this is exactly what we got before. X equals the square root of 4 over 3, which is the square root of 4 over the square root of 3, which I'm getting messy now, which is just 2 over the square root of 3, which is exactly what we got before. So this is reassuring. This means I'm not going crazy, which, well, I need to be true. It also means that if we find the second derivative of this, we will be checking our second order condition appropriately, which again, I'm going to leave to you to do as practice. We can bring this up in class if you're curious and you want to check your answers, but I don't want to deny you the chance to learn by doing. So what have we got? We've got 2 different ways of getting the same answer. Now this way of using implicit differentiation meant that we dealt with these square roots a whole lot less, but it got us the same answer. Rearranging things so that the whole thing was in terms of z and just ditching the y's and the x's entirely, because of course they are functions of z, got us the same thing. It got us the same answer, but we had to do a little bit more with these square roots, but it didn't turn out to be terrible. All right, we'll stop there, and I will see you guys in the future.